Good to see you all. I'm not actually going to do most of the speaking. We have a fun guest to join us, but this morning we're going to talk with McLaren, which is a very interesting and visible user of technology. Most people think that technology is the mechanical type of technology, but it's very much a digital environment, and they could not win without the digital technology, without AI, without data. And so we've had these conversations before. Not to take any credit for it, but this time last year when Dan and I were chatting, they were kind of trying to get their first championship. They got that one, and they got another one, and so they're doing pretty well. So we'll take credit for it, but it's been a great journey for McLaren, and I want to invite Dan Keyworth up to have a conversation. Okay. I guess we're gonna sit here.
Yeah, see that. Thanks, John.
Okay. All right.
I thought the leading-minded AI, I thought that was my intro. And it ended up being yours.
Exactly. Well, yesterday I was like, well, I guess EOB's got that job now, so that's good. I like delegation. We're building a bench of AI people in the world, which is a great thing. Yeah. So yeah, great to see you. It's been, I think, a year since we've talked, but it's been an exciting year. What's it feel like to have a 2 in a row here?
Oh, it's been an incredible journey. I've been with the team 8 years, so. I've seen us come from the back of the grid. We weren't sporting the papaya, which is seen throughout all the stands in the world now. And getting back to the front has been it looks good on paper, but actually it's been a really tough journey as well. And now we get to kind of enjoy the fruits of our labour. Two-time world champions with 6 races to go, although there's technically 9 races with the 3 sprint events, one being this weekend in Austin as well. It's good to have the papaya back on top.
We'll get into some formal questions, but you get to relax for about 3 seconds, because if you take your eye off the ball, what happens in this industry?
Oh, it's genuinely is relentless. And a good example this year is we're quite clearly focused on next year. We've buttoned up the championship, and we've taken our foot off the gas a little around delivering upgrades to the car. However, our competitors continue to bring performance to their car, and that's why you're probably seeing the playing field level a little bit. We tend to say if you're standing still in this game, you're actually going backwards, and that's so true, and you can see some of that playing out right now. But ultimately, if you won the first race in Bahrain and you did nothing to your car, you're likely to come last, probably by 4 seconds. That is the rate of innovation inside this sport, and everyone's out to get each other.
Yep. Well, it kind of sounds like our industry.
Yes, exactly.
It's just faster.
Exactly.
Maybe shifting to some formal discussion. I mean, obviously there's a Dell partnership with McLaren. We've been working together for actually quite a while now. It's been a reasonable, long, consistent journey that we've been on. The underpinning of that is yes, the mechanical side, but the data side, and our relationship started on primarily infrastructure to help unlock the data and interpret it. Now it's transitioning into AI factories and AI outcomes. How has that shift occurred in McLaren from let's call it the pre-Gen AI world to now the Gen AI world in racing?
Well, data's always existed. We kind of don't exist without it, if I'm honest. Everything we do, every small experiment we are making in the factory to ultimately unlock more lap time and performance onto the car is all grounded in data. And we're always trying to extract as much as we possibly can out of it. So yes, our relationship started over 8 years ago, looking at things like mobility of our organization, because everyone was very much fixed to the desk 8 years ago and scared to even leave the office. And now we live in this kind of hybrid state, and we've got the team traveling around the world. And then we focus around our data strategy. How do we contain and manage our data, a growing data set exponentially, in a way that means we can extract as much performance from it. And we've always been doing a level of simulation and machine learning, probably for the last decade. Our data science team have very much sort of been the hub of that activity, but actually we're starting to see perhaps that becoming more citizen-driven as well. So there's more people getting their hands on data and wanting to do more with it. So yeah, we kind of lived in this kind of machine learning simulation phase, and now with the move into Gen AI, we're seeing our ability to gain access to our data and results of our data much quicker. And the barrier of entry and the skill set required is actually lower as well. Yeah. So yeah, it's been an incredible evolution. Obviously, we've had to continually invest in technology to keep up with the curve, keep up with our competitors. But ultimately, I think, proof's in the pudding. You see how we're performing on track. A lot of that is driven by data insight, driven by action taken from that data, and ultimately converted into true lap time.
Yeah, it's like a commercial for what we said 3 years ago was going to happen. Yeah. Gen AI occurred, and it wasn't that AI was new. It was that the way we were doing AI democratized AI for the world. And we thought that, I experienced it at Dell. The day before Gen AI, there were probably maybe 500 people in the company that knew anything about AI and could even spell it. And the day after ChatGPT came out, I had 100,000 people with brilliant ideas about what they were going to do with this thing they barely understood. But it was a good thing, and it allowed us to kind of spread the capability set broadly. Has that happened at McLaren?
Similar, yeah. It's a bit like, I call it almost like an industrialization of Formula One knowledge. Like we can distribute that wider to the 1,500 people that work inside the team, rather than a smaller group of engineers, data scientists, software developers. That's kind of where the data and the ability to understand the data lived. But now actually we're democratizing it in a way that we haven't seen before. And actually our focus around the things that we are developing and the tool sets we're developing, that's shifting and changing by the day. So yeah, it's a really exciting phase.
Yeah, it's funny, at DTW, Neil deGrasse Tyson and I were having a conversation, which was kind of fun, but he made a great point. He said, the biggest shift that's going on is we're shifting from a world where information is power to where aptitude is power, which basically means, once you democratize the data, and even in your world, 5 years ago, there were probably like one guy who knew this specific thing. Now that data can be unlocked and used more broadly, but that one guy isn't about holding that data set. It has a particular set of skills that can use that data. He can adapt. And I think, as we shift into a world where, we kind of accept that the data is available and we can talk to it and interact with it, we can focus on actually doing things with the data.
I couldn't agree more. We find that in our industry, and we're limited by a cost cap now. So it means that you can't spend infinite dollars on making your team successful. So we're very conscious of the number of humans that we can deploy to a racing team. And of course, these are incredibly intelligent engineers as well, and you really want them focused on the doing and the outcomes and driving performance, not necessarily sitting there all day. 70% of their day just crunching numbers, and then they only have 30% of their time to actually go and take any action. So I think, being able to kind of turn that on its head, that's an impressive step, and we're seeing that in real life.
I was at your headquarters and I was in the museum, and I learned a lot about how the Formula One system works. And one of the things I saw was, if you ever get there, it's fascinating because there are some McLaren race cars from years ago that look really ugly, because they have like airfoils all over them. And somebody told me some of these cars could drive up a wall. They have so much downforce on them. But then Formula One intervened and said, oh, wait a minute, no, you can't do that. There are boundaries on it. It's a kind of provocative statement. You don't have to answer it if you don't want. But do you think that the use of AI and these technologies ultimately become such a competitive differentiation that the sport actually starts to try to, at least equalize it, or at least make it less of an advantage, or at least less of a gigantic gap? Because I think you guys are really doing well with it.
Yeah, I think, if you look at the previous eras, the aerodynamics were a little bit wild and crazy, and a lot of that was around interpretation of rules. And this is from people that had been in the sport a long time and could interpret them in a certain way. I actually asked one of our chief aerodynamicists, I was like, what's the saturation point of the next regulation cycle? When do you hit sort of peak performance? And he's like, there is no saturation point. The saturation point, the limit is actually based on the tools and the technology that you can deploy to the problem, and actually it will just continue to keep going. Cool. There's diminishing returns, of course, as you get to the top of the scale, but he's like, there's not like a point where it just hits a ceiling and it flatlines. So it's all around the technologies and the techniques you deploy to this new regulation set.
Yeah, that's good. That's good to hear, because we'd hate to kind of like stop innovating because somebody felt like it could be done. I don't think it can be. I think this is interpretation of data.
And the sport's got a bit of a dilemma. They want to make sure it's an even playing field for the teams. But equally, they want to make sure that the fans enjoy the racing as well, which is why the new set of regulations, the car is slightly shorter, slightly leaner, which is all based on how do you get more overtaking happening during the race. And DRS goes, which is the kind of the letterbox effect of the rear wing. You have to be within a second of a car. Now you have something called X mode, which is where you sort of get a front wing, rear wing effect, but it happens for everyone at exactly the same point. So the sport is always trying to adapt and change, really for the the joy of the fan, but it's just another engineering challenge for us, and we quite like change because it means we get to go and solve new problems.
I always tell people I'm an engineer, so I'm okay if technology doesn't work perfectly and all problems haven't been solved. That keeps me employed.
Yeah.
So on the technical side, you and I were chatting. I asked you, I said, how much data do you have these days? And your number is pretty big.
Yeah, like it's in the range of petabytes. It's we do a lot of kind of upfront simulation before we even commit to building a race car. Project we worked on back in really when we started to see the trajectory of performance change was something called CFD, so computational fluid dynamics. This is in effect a complete digital twin of the Formula One car, and it allows our aerodynamicists to iterate and change the flow physics around the car to go, what concepts are actually working for us. And the flows around a Formula One car are so sensitive, so you make the smallest change to a front wing flap, and then it can completely blow out the way that the car is performing on track. So this is a constant cyclical iteration. Once we're kind of happy with a concept, we then go and confirm that in our wind tunnel. We build a 60% version of the Formula One car through rapid prototype techniques, and then that gives us another data point. So we've kind of suddenly got digital simulated world, and then you've got your first indication of physical. We then have other kind of test cases like putting it in the driver simulator for Lando and Oscar to go and prove out a potential setup of the car alongside the aerodynamic characteristics of the car. And then, of course, you get the real thing on track. Yep. Yeah? And this is just like the cycle of our product. So it's, product lifecycle management for any organization happens like this. You're constantly closing the loop based on the data you're seeing through the cycle. And eventually you get the product for us, which is a Formula One car on track. And then that's when all the correlation and all the big work starts to happen.
Maybe shifting gears, let's talk about kind of the other half. The core data processing piece is super important, but then you have still people that haven't been replaced by AIs. You have and those people have to work, and so we've had a lot of interaction around kind of arming your developers, arming your technologists with PCs over the year. You're a big precision user and other technologies. Now we have AI PCs. Mm-hmm. What's your view on kind of the need to carry the engine that can run the technology with you wherever you are?
Well, I think when people talk about, in our world, when we talk about edge, most people think, it must be the mobile data center you take to every race and you drop that into your garage and that's where you do all of your sort of core processing. But actually, the edge resonates inside the laptop as well, right? You can do way more in the hands of the user. And for us, there's a huge amount of mobility. We've got engineers that are traveling the world, particularly on planes. And we do a lot of our pre-game work, actually, perched on a plane, going, doing all of our simulations, looking at our kind of previous telemetry analysis, deploying some, models that the team have developed, and doing that all locally on the laptop. So, things like battery life and performance and all these things that are just kind of the basics that you really always want to work well. They've also got to keep up with the curve of the technology as well. So, yeah, we've certainly seen some incredible benefits, both from the knowledge worker that's probably using things like copilots and AI locally on their PC, through to sort of the hardcore engineer that is doing simulation, gameplay, and running perhaps some slightly heavier models. I think that's that feels like the future for us. It's kind of having rather than having the trackside rig kind of in the plane, it's like you've kind of got that in your hands, and I think that's a super exciting step for us.
Yeah, you're kind of in that first wave of the productivity apps are very obvious in AI PCs. The battery life is better, the performance is better. That's pretty straightforward. And there's lots of ISVs that, whether you know it or not, are using NPUs. Yeah. There's this other way of coming, which is people are actually using very specific AI techniques on the system. We have a customer that we're working with that it's a prototype. They are running 5 models concurrently on an AI PC, and they're distributed across the GPU, the NPU, and the CPU. So, in your world, do you see the future of your technologists actually kind of having a multidisciplinary or multi-domain kind of need for AI? That it's not just a tool; it's a platform to run whatever models you need to run and whatever tools you need to run wherever you need to run them.
Well, exactly. I think, rather than looking at it as a tool, it's definitely a platform. It's a suite of things that you can deploy across your team. It also makes us think about how do we develop these things going forward as well, right? There's models that we haven't yet developed, and actually it's like, how do you best put those in the hands of the users to get the best impact from? So I think, as the technology evolves, we're not going, we're going to do it the traditional way like we've always done, and we'll continue to be advocates of that, and actually then we'll start to fall behind. Really, we're looking at how's the technology evolving, and how do we kind of keep at the pace of that, and that's changing probably the way that we're developing models as well.
Yeah. And it does sound like your teams are able to keep working wherever they are. You have this from blackout mode, which is like when you're not at the track and you're not at the office and you're traveling, there's still work that needs to be done.
Yeah, you're really restricted by the amount of time you can spend at the track, and you're normally hooked into the session that's happening. Yeah. So you'll be trying to get like the car dialed in for the weekend, so you're very much focused on the output of that last session, and then you're debriefing with the team. But actually all of your kind of pre-game thinking, and then also post-analysis as well, is all done whilst you're on the road, sitting in the hotel, perhaps the slightly less glamorous life that you don't see on TV.
We just have a lot to do, and unfortunately, the time to do it. But the thing that will inhibit people from doing more work or being able to do the work when they need to is access to the tools. And I'm super excited. Like we just tomorrow is the launch date for the GB10s and which are these very small, very high performance AI PCs, and they're more desktop ones. But I'm super excited about that because I can see all these things that I can do without having to go into a data center, and they're mostly around large models, large memory footprint. So, what do you think the state of AI in racing is going to be a year from now?
The continued ability to unlock our human talent, almost having AI as kind of the secondary engineer in their life that is doing some of the laborious things that they just tend to not enjoy doing, or is taking them away from that free thinking space to be a good scientist, to be a good engineer, which we know ultimately converts into performance. I think where we're seeing improved ways that we can ask questions of our data as well, whether that's through natural language, or whether that's through scenario planning. You don't have to kind of interrogate models in this way that you used to and kind of extract the information and cram it together. You can just say, show me a lap between Lando and Oscar in Q3 in Belgium for 2025, and show me now 2024, so I can see a live comparison, and all of that just suddenly appears in front of you. That's really exciting for me, because it knows that all of the hard work we're doing in the background, we can surface that to the team much quicker and much better than we have done before. So I think it's kind of, there's a little bit of there's a more of the same, because we've seen some green shoots of some things we're really excited about, and also we'll just keep an eye on how this technology space continues to move over the next 12 months. A lot's happened in the last 12, so
exactly.
Let's see where it goes.
Yeah, I think one of the things you're hitting on is, there's a shift going on right now, and it's driven by advanced AI, but also agents, and it basically says that up until this point, most knowledge created in the AI world was created at training time. And if we look forward, the vast majority of the knowledge is going to be created at inference time. It's going to be knowledge graphs that get created. It's going to be derivatives. And that is very, very interesting, because there's a lot more inference out there, and there's a lot more human interaction with inference than there is with training. And so that dynamism is going to be fascinating.
Yeah, agreed.
Just summary, look, one of the things we love about working with McLaren is, you have this high performance, constantly changing industry, very data driven. And the most important thing is when we apply our technology collectively to that problem, we can actually measure the results, because they either win or don't win, and it helps us understand, is this all working? So Dan, thanks for being our partner, and it's always fun to talk. Great to talk about everything from infrastructure to the client devices, and it's kind of demonstrating this is a pretty pervasive technology suite that we have to apply. So
yeah,
great. Thanks for being here.
Thank you.